Kvaskova.
Okay, how you were able to hear me?
Can you move Karina closer to you?
Okay.
Yeah, so thanks for joining. This is Karina. My name is Dmitry and welcome to our yet another DevOps meetup. Can you hear me? Yeah? Okay. So as you may see, here is a DevOps LV sign. So that's the place which we are trying to promote. So if you are not aware about it, join our Facebook group, visit our page, and also you can join our Slack channel so you can hear and know about DevOps events. So we are trying to promote DevOps culture in Latvia. I almost said Russia, but yeah. Also we'll try to promote it in Russia. So we will have today two presentations. So first one will be Karina. So welcome.
Okay, yes. Hello, my name is Karina, and I'm from DevOps team. So I have prepared a presentation about DevOps architecture capabilities and components. And it's basically a story about our project. So what we do in our project, how we select which capabilities are important for us, and which components we use to implement them. And let's start. So about me, I'm working in Accenture around 6 years, and all these years in DevOps. So I'm DevOps engineer, and I'm a team lead in DevOps team in the project about which I will speak today. So of course there will be no specific project details, so all about tools, about processes. Yeah, and agenda will be a bit about the project, so how we work. So we use Scaled Agile framework, a bit about it. And next will be review of the capabilities, components, and in the end, I will show you the continuous delivery pipeline, where we have all the tools and components described during the presentation. So about the project, we use Scaled Agile framework. So it's actually agile methodology in the big team of small teams. And we have distributed teams. Some teams are abroad, some teams are in Riga. So we all are in small agile teams, and we have all the ceremonies to collaborate according to Scaled Agile. So that is why for us it's very important to enable DevOps culture for the teams in a distributed environment. So in our team we are 5 together with me. What is important, that the requirement by client is to have on-premises infrastructure. So it means that we do not use cloud providers. So we also do not manage in our team by ourselves infrastructure. So it is done by a third-party company. So actually we configure it, but the management of the infrastructure is responsibility of another company. Let's start with the capabilities already. And well, as we are in a Scaled Agile framework, we are many teams in one big team, so-called Agile Release Train. And in each team there is a Scrum Master, and during the sprint, Scrum Masters meet together in a Scrum of Scrums, so where we discuss what happens in the teams, so blockers, some issues which can be like dependent on another team's issues, and this is solved during the Scrum of Scrums. That is why it's very important for us to enable program and project management capabilities. So we use Jira. I hope you all see. We use Jira as a main tool for this. So this is needed for planning and project management. So actually we have sprints, 2 weeks each sprint, and each small agile team has a planning meeting in the first day of each sprint. And together, all our teams have increment planning meeting. It's once per 5 sprints, so once per increment. And Jira is really useful in this case. So we use multiple plugins, and some major from them are Script Runner for Jira, Portfolio for Jira. So Portfolio, I think if you use Jira, you know that this is very commonly used plugin now for scheduling, for planning. It is not free, but it enables all the teams be on one page. So all the teams and usually Scrum Masters, program management use boards and review high-level planning. And the epics link to work across all the teams. So actually we are, as a team, using our own board where we have our own issues, but they all are visible through this portfolio board in Jira. So with this component, we enable many things. So we enable planning, scope management as well. So teams plan the work inside sprints, move tickets to the board, to the planned iteration, or plan a full increment each sprint. We also implement change management and control. So all the issues are registered in Jira. So everything is registered with acceptance criteria, and all change requests are there. Issue and risk management as well. So we have a special board for Scrum Masters. It is board with the risks, and there are separate type of the issues where we can write the risks in our team and then discuss in the Scrum of Scrums meeting how we interact with other teams. So if there are some blockers, or if we are blocking somebody, or some teams block us. And of course, some reporting. If you use Jira, you know that there are many built-in options. And of course, you can customize stuff. Script Runner for Jira is also a very useful plugin for us, because as you see, if there are many teams, so all the teams want their workflows, some specific filters, and Script Runner for Jira allows us to have many functions. So it's like extension for out of the box, which is available in Jira for free. So Script Runner also is not for free, and it is addition great option with the functions where you can, for example, have a custom field and calculate their values according to your need based on the input in another fields. So this is highly used as well in the boards to calculate, for example, importance of the tickets, how quickly the program management would take them into the plan. So many values needed for estimations. calculated with this script runner for Jira. And so, as I mentioned, the main point of backlog, you can plan your work capacity as well there, and get reports. So of course there are built-in reports, and if you need something custom, it is important to review if there are such options to customize or maybe to use a bit another report. So if you have some questions, maybe let's discuss after the presentation so we can return to the slides and discuss in more details. So second slide is also about program and project management capabilities, and there is a subsection, resource and collaboration management capabilities. So it's actually how we collaborate. We, as a distributed team, are really in a big demand of a great collaboration tools, because we need always to reach our team members abroad, and team members who can be not abroad but not sitting near at the moment. And not only the communication in the team is in this section. So for example, when you write a comment in your Jira ticket, you collaborate as well. So you you have a history there. You can see what other team members said about this ticket, why it was done, why some discussion appeared. So that is why here I mentioned several tools, not only tools for communication, but also Jira, where you can see comments and history in your issues and collaborate there with team members according to the need based on this request, based on the bug registered or change request. Of course, Confluence. So all the documentation we have in Confluence. It's a great collaboration tool and document management tool. So we have wikis, we have how-to guides, and when we plan something, we create plans, and they can be draft work-in-progress plans, and everybody can comment. So that is also comments, history, and based on this you can analyze what is going on regarding this document. We use Bitbucket as well. So Bitbucket is a web-based tool above Git. So it is Atlassian tool, and it's like web UI. So where you can see branches, where you can see your code. And in this tool, you can easily create pull requests from one branch to another branch, and specify reviewers for your pull request. And then communication can continue there. So your comment, so your ideas and or your suggestions about the code, if you, for example, see the better way how to write the code, or if you know that, some changes will appear soon and this code has to be rewritten a bit. So all of this is in comments, in pull requests, in Bitbucket, and it is also a great collaboration tool about the code. And of course, SharePoint, Microsoft Teams. So it's like place where you can create chats with team members and communicate as well, and share some pages and wikis as well. And the Mattermost we use widely in the project between distributed teams. So it's also communication tool with the teams and channels inside. So you can make some private teams and channels to communicate. So actually, all of these tools enable the collaboration and resource management, and we support and administer those tools. We also are responsible for upgrading them, so it's our part of our usual work. Backup, restoration from backup. So we periodically test our backups and test how we can restore them, because after upgrades, changes happen, and we need to ensure that we can restore our backups. So these tools administration takes much time in our daily work. Let's go further. So it's number 3 slide, program and project management section, agile project management. So here as well, Jira and Confluence. What is in this section are this possibility to view and to see work in progress for your team. So have boards, visualize how you are doing. So you use backlogs, you can drag and drop according to priority, top priority items to the top. If you, for example, use Kanban methodology, so take the most important from the top when somebody is free and enable this workflow. And our team, our DevOps team works per Kanban methodology, so we still have like cadence with another teams. We have 2 weeks for plan, but we reserve much time for support tasks, for some more important tasks. So, and another part of the time we plan improvements, automation, and everything we need to support the capabilities. So in our team we use Kanban boards. We have like a ranking to enable what we will prioritize first. So some teams, majority of the teams work per Scrum. So sprint is planned and teams adhere to exactly what is planned. Usually it is for development teams who work on particular feature. So also Confluence is used here with the purpose to have retrospective management. We have great options in Confluence to have already prepared nice pages types where you can select retro and you will see already template for your meeting, and we use it. So we already have there how we are doing, what was great, what was not so great. So and of course each sprint we discuss it and document. And of course, test-driven development, behavior-driven development. So you can write stories in Jira and specify, like, as a user, you want to do this and this to get this and this. And actually, this is a great tool also. So to register all your stories for developers, who then afterwards will select them in the sprint. So I think let's go further, and I forgot to mention burn down charts, also built-in graphs in Jira, so you can select them if you are using Scrum and visualize how much work is done and how much work is needed to be done in the sprint by the team, in order it is going in the correct and in a good manner, not like parallel all the sprint and then at the end you close all the tickets and hey, you are ready. So yeah, it should go with a suggested way that you close tickets all the time during the sprint. And these tools are very useful also for project managers and program managers to review how work is done. So next, build and test capabilities. So here, Gradle as a build tool, Jenkins, of course, and the bucket here mentioned. So in the first slide of the build and test capabilities, there are mostly build and integration enablement capabilities. So Continuous integration, build orchestration. So these are the main capabilities from this section. So interest of our team and daily work. So we use Gradle to build and package software and some needed files, for example. So we have RPM packages, and they are used widely in the project. We pack their software, we pack their some configuration files, and even some configuration files for the tools like Confluence, Bitbucket, Jira. Jenkins, of course, built servers, so we orchestrate almost everything with it, what we can. So we have pipelines, we have continuous integration, continuous delivery. In addition, we make some process automation. We have scripts and we run them from Jenkins as well. What I mentioned here is like main thing that we use Bitbucket plugin in Jenkins. So it is the plugin which gives us option to have a trigger from Bitbucket when commit is made and push is made to the repository. So previously we used built-in options like polling from Jenkins all the time, Git repositories, and we got some warnings and issues in our Git, so written in the Bitbucket UI, like out of resources will be soon or something like that. So we decided that we not poll each minute the repositories for changes, but we will trigger a job from Bitbucket when some change push there. So Bitbucket plugin in Jenkins helps us in this case, and actually working good, and it is free. We also use Jenkins auto jobs. In the next slide I will show some details about it. So what does it mean? It's also like plugin, but how we use it? We have templates where we have some code how job should perform, and these auto jobs working all the time, like once per 10 minutes, and it checks if a branch appeared in the repository, and when branch appeared, according to configuration, of course, so some particular branches, some particular repositories, usually it is bug fix and feature branches, it creates a job from template and job started. So in this way we enable that developers have continuous integration immediately when they create branch and then commit their code to the branch. And good point is that when developer finished and like fixed the bug and branch is not needed anymore, and after the merge of this code, developer removes the branch, and this auto job also removes the job in Jenkins. So they are only when needed, and we like them actually. Working good for us. And yeah, so to enable Bitbucket plugin in Jenkins, in Bitbucket we have to specify post webhook. So it's also like connecting together Bitbucket and Jenkins from the both sides. And if you are interested, you can find information how to connect in the documentation in the internet, so it's described very well. Also, we widely use Gradle to generate configuration files from templates. So usually we have some standard, commonly used configuration, and configuration which is dependent on the environment where we are going to deploy our application. And so with Gradle, we generate needed configuration files from the template, from the properties needed for particular environment. So currently working good, but maybe we will replace it because we have more and more environments, and maybe something else could be selected. But also great tool to generate something and insert into your properties file. So let's go to the next slide. So here is a bit about this trigger, so Bitbucket plugin. Only example, so I took from somewhere, it's not real URL, and you configure it for each repository where you need it. And for example, we use on push usually. We have not tried any other options. Maybe they can be also useful for somebody. And in Jenkins, when you install this plugin, in the job configuration, you see you will have the appeared option built when a change is pushed to Bitbucket. So in this way, it is configured. And auto jobs. So here is a bit about it. So also Jenkins auto jobs is available in the internet, the documentation, if you are interested to have it. And so templates, and we use only bug fix and feature branches. So there are YAML files. So basically configuration about from where you would like to get these auto jobs. And we specify some particular projects in Jira, and we specify repositories and select bug fix and feature branches in order, for example, if it is not, if it is our team, like DevOps team, so we don't want to create a template job to compile if we simply test some configuration. So our project is excluded. So developers can test code not only locally, but also actually with the same job as Jenkins will build and compile when they will merge the code to the remote repository. So it's like also good option in addition to the local testing. So let's go on further. Slide number 4, and in this section, test management capabilities, test execution, and automation capabilities. So we have either automated testing or manual testing. So for manual testing, we use Zephyr for Jira add-on. So also great add-on, and it's not free, of course. So all great things for Atlassian tools probably will be for some money. So manual testing, you have a test type of issues when you install this add-on in Jira. And when you create a test, so you will have a great form so to specify test steps or some other related to the testing options. And then they are combined to the test executions, the test cycles, and you have great reports. So actually for manual testing, really great tool, and used in our project as well. Also we use unit tests, so JUnit. For performance test, we use Gateway, and this provides nice reports in Jenkins. So in our pipelines, after deployment to some environment, we want to run functional tests, some other tests, and usually we use Protractor with Yasmin together. So there are generated HTML reports, and it's nice in Jenkins because you go inside pipeline and you see these reports already there. So very, very, very beautiful, I would say. And for security testing, we use OWASP. So it's like also one of the steps in our pipelines. Actually, this is not in all pipelines, of course. This is in pipelines mostly for a backend deployment. Yeah, let's go, I think, further. Software configuration and release management capabilities. So Jenkins, Docker, Artifactory, Rundeck, and Bitbucket also mentioned here. So what is inside these capabilities section? So version, release, and artifact management, of course, and some deployment capabilities. For versioning, version management, so as I mentioned, we use Git and UI, Bitbucket, Atlassian tool, and it is integrated with other two Atlassian tools, Jira and Confluence. So actually, for Atlassian tools, if you use them, if it is possible to buy them for the project, it's really great because they can be nicely integrated together, and you leverage from it. So we use Artifactory as artifact management system and also dependencies management system, because we store there either dependencies for the builds, some libraries needed to perform the build, and also already prepared artifacts from the build. In Artifactory, we have internal Docker registry. So officially, it is not recommended to use it as a production Docker registry, but we use it, and actually it's okay for us. There are some like interesting details, but actually works for us good. So we produce images and store them in the Artifactory. So in Docker registry, which is configured in the Artifactory. And so deployment options. So continuous delivery pipeline management. It happens in the Jenkins using the pipeline plugin. So pipeline, you install pipeline plugin in Jenkins, and during this pipeline installs all needed, some 10 or more, I think, I not remember exactly, needed plugins for itself. So it's like a pipeline big section of the plugins. And we use Jenkins files, so we like Jenkins files much. So good to have all the code of your build jobs, of your pipelines together with the code, because they are in the root of the repository. And actually you can use scripted and declarative syntax. Well, initially we started to use scripted, and now we already start to use declarative for some of the pipelines, because there are some benefits in the declarative syntax. And we use Docker for containerization, so all our components of our big application are in containers, and we have Docker files. And it's great to have both Docker file, Jenkins file in the root of the repository with the code, and have all in one place and see history. So it's a really useful for us, and everybody can see what was changed. So, and you can reuse. So you created one Jenkins file for one pipeline for one component, and you simply can use it for another one. Yeah, so together, Git, Jenkins, Artifactory, and branching strategy for to manage change of software assets. So we have a particular branching strategy. So we know where is the main development stream, where another development stream of features, or some big program features, and where there is a production code. And of course this is evolving system, so we like in DevOps and in Agile, we continuously learn and adjust something, change something. And we use Rundeck. It is a task scheduler. So actually in our pipelines, we when we need to deploy something, we execute Rundeck jobs, because how you can use it. You can configure one job and specify multiple environments in Rundeck, and this job will be going one by one in each environment. Actually, it is great for some purposes, but as we are all the time improving, we plan changes. Maybe we're now considering Docker Compose or Ansible for deployment to some environments. But this tool is like working from long times, and actually maybe some changes will be. But if you need to schedule one task and execute on multiple environments, it can be a tool for you. So let's go further. Quality and knowledge management. So in this slide, quality management capabilities. And of course, we use SonarQube as a static code analysis. So we like it. A great tool. So there are visible some bugs, vulnerabilities, code coverage, and great option to configure quality gates for your Jenkins pipeline. So it's like when everything working good and your code is compiling and everything green, and SonarQube can, based on the rules which you activate, so it's also up to you to select which rules should be activated. SonarQube can identify, for example, some not good code standard, or like code smells, it calls in the SonarQube. So, and if you select this as an important quality gate, you can simply fail the pipeline and not allow to have an artifact prepared from this not good code. And of course, great tool, but you need to spend time to set up all the strategies. So which rules you need, maybe some of them are like false positives, so which of them are really needed. Define, for example, which minimal code coverage in your project is allowed for you to go with the code further. We use Sonar for Bitbucket server add-on in Bitbucket. So this is an option where we can see analysis inside the pull request. So when developer make a pull request from their bug fix branch to the main development stream, already in pull request, before it is merged to the main development stream, we can already see analysis. So like if all is good, or if some new bugs or vulnerabilities are introduced exactly by this pull request. And we do not prohibit the merge in this case, but we are planning. So this is also a good option, that you can disable the button merge, even if everybody approved from the reviewers. You can disable this button because in Sonar there is found some not good vulnerabilities. And of course, defect tracking Jira. So all bugs are registered in Jira, and it is great that Jira, Bitbucket, and Confluence can be integrated so much together, because you can see a branch in Bitbucket inside Jira bug, and you can see a comment in the pull request and go directly to the Jira bug to see, for example, acceptance criteria, to understand if you are really going to approve it, if you are the approver. So, and here is also a picture from the internet, simply a view how it looks like when you use this Sonar for Bitbucket plugin. So it is a part of the Bitbucket pull request overview. It's different, so where you can see which files were changed, some commits, and in the right side there is analysis of the Bitbucket. Important point is that in order this happens, you need already existing analysis in SonarQube for source branch from which you make a pull request into the target branch to which you make the pull request. And this is enabled for us by these auto jobs for the developers and Sonar is inside, so after the compilation and build. So that is why we always have source and target branch already analyzed before the team member decides to make a pull request. Quality knowledge management capabilities. So Confluence. So as I mentioned, all policies, standards, everything is in Confluence, and collaboration management, knowledge management. And for us, we found very useful couple of add-ons. So of course there are many, but some of them are really useful. These scroll versions, scroll translations. So to translate to multiple languages your space, and scroll versions also to version whole space. So you can, for example, in the end of the sprint, publish your space and with a specific version. In order you know that during this sprint it was this documentation, during another sprint this was another documentation. So in case you need to track something and you need to track changes. We use also team calendars add-on, so to plan, to have one calendar for all events for the team. And I have not mentioned here, but it's very good, these diagrams, Draw.io or Glyph diagrams, also second add-on. So when we need to write some architecture, like pictures, how we are planning our tools and our components, and actually everything we can draw with them. So IT operations management. So environment configuration management, we use Puppet. So actually we use Puppet for all environments configuration, for local environment configuration, for integration test environments configuration, and further. We also work on some backups, but usually we back up with the scripts all the tools, and we have standby servers to test our backups and to restore on them. So cron jobs for scheduling we use much, so and also Rundeck as well. So and Zabbix, so system service monitoring. Jenkins, of course, is also included here because it's orchestrator of many of the backup jobs. And of course, we write automation scripts, bash scripts. We have many of them. Security operations management capabilities. So here I mentioned mainly user server and access management. So we use Jira as access manager, user manager for the tools SonarQube, Artifactory, Bitbucket, Confluence, and Jenkins. So it's very convenient when you have one place for credentials. You manage groups, and based on this, you provide access to the teams, and so all in one place. And team members can easily log in to all of these tools with one set of credentials. So here can be a trick that, for example, when we upgrade Jira, for example, we still have a downtime because it's Jira on server, and it's very big, but it is okay with the client. So still, if you do this upgrade, then your user server is not working at this moment. So this is a trick that everybody should be informed and remember that, yeah, so if you want to log in then to all of these tools, then you need to wait when maintenance break finishes. And for application, it is used LDAP. Yeah, so where application-related groups and users are managed. So patch management, antivirus management, and some server security, so as I mentioned, it is managed by third-party company, so we usually support it, so we are together with them online when they make server operating system upgrades, but actually we do not do by ourselves. And well, this slide is about environment. So environment is also a component to enable capabilities discussed previously. So we have local environment. So it's Vagrant with VirtualBox, where developers make the VM. And it's, of course, as well configured with a Puppet. And other environments are configured the same way with a Puppet. Of course, they are not 100% same, because we have some differences. And we have first step for continuous integration. It's integration test environments where our pipelines are deploying. And we have also client test environments where we can deploy either pipeline, either client can test manually something there, and we can stop automatic deployment of the pipelines. Performance test environment, so high load for performance testing during nights and on particular requests as well, according to the plans. User acceptance test environment, so it's like environment where client tests manually or something is automated as well there. Training environment, it's the environment where so the client and stakeholders test the application and train. So when new features already come. So actually not test, but train how to use it. And staging in production, so two environments where production is the end environment and staging, so before the production. And of course, we have tool servers. So we have Jira, Confluence, Bitbucket, Artifactory on each server. And we have standby servers for, first of all, for upgrade testing. And we have automation for disaster recovery in case those servers are not working and can't be restored. So we can restore our backups on these standby servers. Rundeck and Jenkins, we run Jenkins in containers. So actually now we have 4 instances where we have in one of them auto jobs for developers and 1 performance test going and 2 instances with pipelines. But actually we are planning to remake a bit and make master-slave architecture, because previously, well, we used simply master because we had many instances of the Jenkins. And now we will leverage, because we have many auto jobs, many pipelines appearing, so we need to leverage from it and use efficiently the resources. And SonarQube, Mattermost, Zabbix, so all is running in the containers except Atlassian tools. So currently we do not run them in containers. And so here is a continuous delivery pipeline. It's actually, I'm not sure if who is sitting there you can see, but I will describe. So actually this is an example of one of the pipelines. So from the point when developer starts working on it, on some bug fix or feature, till the point when we get feedback for this code. So here also all the pictures of the tools we mentioned in the previous slide. So everything starts when developer gets the bug or feature to develop during the planning, and when sprint starts, so teams start to work, and the developers have VMs with Vagrant and VirtualBox currently. And they are configured with Puppet and auto jobs. So when developer creates bug fix feature branch, there will be a job for CI for this purpose. And next happens this development, local testing. Auto job will test and make sonar analysis. And when developer is ready, the pull request is made to the Bitbucket from this feature branch or bug fix branch to the main development stream. We have a configuration of the default reviewers, so many people are included in this pull request to review what's happening. And at this moment, there is already sonar analysis, delta, so if no bugs are introduced from the perspective of the sonar cube rules. And when approvals are available, the merge button is active and developer merges pull request to the main development stream. And next, Jenkins job is triggered. It is pipeline. What happens in the pipeline? Build, then sonar analysis as well. And after the build, there is an artifact which is already published in the Artifactory. And during the build, some libraries are taken from the Artifactory's dependencies. And if all is great, then integration test going. But for some of the pipelines, they can be without integration test. So it depends on the preferences of the decision of the team, of the architecture, and so on. And when all is great, we create image. We build container and store image in the Artifactory, in the internal Docker registry there. So as you see, firstly, it's like go in Jenkins file, and now we build with from the Docker file available in this repository. And then when we have image, so now we can deploy it actually to all the environments. In this automatic pipeline, we deploy to the integration test environment. During this stage in the pipeline, run the job is executed. At this moment, we use it. And it deploys to the particular environment according to the configuration, because many teams, many branches are assigned to particular environments. And then when all is deployed, regression test started, and there is used Protractor, Yasmin, and there are created HTML reports based on these tests. And the HTML report can be visible in each pipeline build. So you actually can see a nice picture or what is inside the report. And as we use components as containers, so our application can consist of many containers and different components. When we deploy some of the component and when we test it and we see that it is great, it is working, and it is tests are green, it means that this version of the component works correctly with another components already installed on the environment. And manifest update stage is the moment when there is prepared a text file where there are written versions of all the components in the environment. So proven that they work together by the regression test stage previously executed. And now we have a manifest. So actually we have a full version of the application with all the components, underlying containers, which can be deployed further to any environment for testing. And if it is successful, then to production as well. And then at this moment, integration test environment deployment is already finished, and we have a manifest, so this file with versions, and we use promotion options in Jenkins. So you can select this job which created the manifest and promote it to any environment. So you can promote it to user acceptance test environment, to training environment. Of course, usually it is done like firstly to the client test environment, then to the user acceptance test environment, and then it goes already staging, production, and training. So still you can promote to any environment based on your needs, and usually it is done by the test team where also client involved, so happens testing, and we receive feedback from the code. So feedback according to this new manifest. So either some new bugs can appear, or some ideas about new features can appear, or this feedback can be and should be registered in Jira and these are new issues. And they are going back to the developer. Of course, it's not like automatically developer takes them and develops, because next planning it will be discussed, decided with the product owner of the team. So if and what should be taken further. But still, all this feedback is written in Jira and stored. So it's not lost. And all this happens together, of course, with the documentation, Confluence, and collaboration tools like Mattermost and Microsoft Teams. So teams discuss, analyze, discuss reports, discuss where they want to deploy, and so on. So overall, this is like collection of the components to enable the capabilities in the project for developing the product. So, and actually, this is all for today's presentation from my side. So thank you very much, and if you have questions, you are welcome.
Yeah, thanks to Karina. Let's have a break, like 5-10 minutes, when Oleg will prepare. Well, so I have 10 minutes. Okay, let's have 10 minutes. Yeah.
Okay. Yeah.
Very good. So let's say hi to Oleg, who will tell you about really fancy things. So stage yours.
Okay. May I proceed?
Yes.
Good evening, everyone. Thank you for joining us on this meetup. My name is Oleg. I'm a DevOps engineer here at Central Latvia. And the topic of my presentation is how we sending AWS CloudWatch alerts to the Microsoft Teams. My client is an internet shopping company. That's it I have to say about my client. I'm very sorry. So let's begin with content. First of all, purpose of my presentation and why we choose Microsoft Teams, not Slack, not Telegram, not WhatsApp, and so on. How does it look schematically? How we implemented this solution? How does it work actually? Main principles. What it could be used for? A real example from our infrastructure. Also, I think it's worth to mention tools which we used in real implementation and tools used for making presentation. And if you will have the questions, I think you may ask them when I will finish. So, main goal, make idea visible to others and explain implementation, but not in very deep details. Why we choose MS Teams, not Telegram, not Slack, and so on. Our former messenger Slack, and we decided to switch onto MS Teams because we use Office suite extensively for collaboration. And since we use Office, we don't need to pay for using external messenger anymore. Here you can see the common theme. We used CloudTrail, CloudWatch, SNS as transport, and Lambda function for running our function code. And the last is the Microsoft Teams Messenger. So, what we did for implementation? First of all, we create function which is written is in our favorite language. AWS Lambda supports Node.js, Python, Java, Ruby, C#, Golang, and PowerShell. And then we can use default trails or create for custom ones. I can explain the difference between CloudTrails and CloudWatch. Actually, Trails used for catching events in infrastructure. For example, accounting events, resource usage events, and so on. And CloudWatch used mainly for aggregating logs and monitoring, and so on. Both CloudTrail and CloudWatch could be used for alerting. So next step, configure Trail to send events to CloudWatch logs group. Also, we need to create a log group. Then we need to create SNS topic and endpoint or subscription. Endpoint is our function. Then we need to create alarm and configure it to send SNS notification. Then we need to create TGIN action for Lambda function because we need min to say our function to send message to Microsoft Teams. And the last step, the most simple one, the simplest one, create a MS Team and channel, get webhook URL for this channel, and pass webhook as parameter to our function. For example, define variable in secrets manager and import it in function configuration or save it directly in function code or configuration. What it could be used for? For example, IAM, events alerting, root account usage, admin group assuming, etc. Infrastructure events alerting, EC2 instances rebooting, for example. Adding, deleting, changing resources such as queues, topics, instances, and so on. How does it work actually? CloudTrail catches event, then CloudTrail passes this event to CloudWatch, into CloudWatch logs. CloudWatch raises CloudWatch alert, and SNS using Lambda protocol, in our case, delivers this event as a text message to Lambda, AWS service, and then Lambda triggers AWS Lambda function, and function sends using HTTPS as transport this message to Microsoft Teams using given URL address as destination. What we used in implementation are AWS services such as CloudTrail, CloudWatch, SNS, Lambda. Language was Node.js, JavaScript, and Node.js framework. Terraform we used for manual deployments in non-leaf environments, and for deployments in leaf environments we used GoCD together with Terraform, and pipelines written in Bash and Python. Main idea, GoCD runs pipelines using Terraform and Bash scripts. Which tools I used for creating this presentation is CloudCraft Co, where you can choose AWS icons like this. Official AWS documentation and Microsoft Office suite. If you have any questions, I can answer them. Thank you.
Would you share your code? Or is it
I'm sorry, it's not possible.
possibly there are some referrals or URLs for implementation examples?
Repeat please.
Yeah, well, accessible, which are accessible worldwide. I mean in internet.
It will not be accessible worldwide. In any case, it may not be accessible worldwide.
Have you used, for example, to write a Lambda, some references which other people also can use to process the alerts? Or you invented everything by yourself?
My role was just move alerting from Slack to MS Teams, and that was it.
So the Lambda was written before, so you just
I just recreated. Okay, it's okay. I just recreated the code, but in another language, and I used other messenger. That was my role.
Okay, can I ask, like, if we remove Lambda and put Jenkins and make SNS send a webhook to Jenkins, and then Jenkins already have a plugin integrated with Team Chat, so it will be easier, less code, and more visible.
It will not be serverless then?
Yes, it will be not serverless, but it will be more, and it will be cheaper.
It could work also. It could be cheaper. I agree.
But why it will be cheaper?
Due to you have already Jenkins, should be in your
If you
code.
have it.
It should be, or another webhooks, and just you already have it. You don't need to implement a new thing. And Lambda, you pay for it.
Oh, you pay as long as it runs.
Yes, but if you have a lot of alerts, it will be cost so much. They're just like another way of implementation.
But using AWS Lambda is kind of more flexible than Jenkins. If you need some customization, you can just update the function and that's it.
The same like Jenkins. Can you change anything?
Jenkins is down.
Like
Yeah.
And the last question, if you want to, did we correctly understand what you're practically using one Lambda function per alert? Different alerts, and they all also demands different Lambda functions.
Why do you need different Lambda functions for different?
You're using just one
Yes, just one.
for whole pipeline?
Yes, of course.
Okay.
It will cost more money, resources, and so on.
Anything else? So if not, then thanks, Oleg. Nice presentation.
Thank you.
So thanks for joining us. I hope you liked the event. So please come next time.